Hi everybody. So I'm just making this video to help out with this idea of mutually exclusive events. And so I'm going to zoom in for a second or get close up and we'll read it and we'll try and answer the two problems that are presented. So it says events A and B are mutually exclusive. So mutually exclusive basically says that there's no overlap. So our events A and B on the world of the Venn diagram are just like two independent circles. If they were not, you'd have some kind of overlap. So the circles would look something like this, like that. And so you'd get this region of overlap. And that's where they share possible elements in the set. Okay. Erase this real quick. Now, in our problem, it says that the event A occurs with probability of 0.08 and B occurs with a probability of 0.15. And what that means is that if the probability of A is 0.08 and the probability of B is 0.15, then the complements, and please note Alex uses that horizontal bar over top, so A complement, B complement. I tend to write AC and BC, C for complement, is 0.92 and 0.85. They add to 1, these add to 1. And because they're mutually exclusive, ME stands for mutually exclusive, there's no overlap, so the probability of the intersection is 0. And so what you have to kind of think about, particularly to deal with this problem, is that B complement is this space out here that's not in B. And so A is all part of B complement, and vice versa. B is part of A complement. So the first thing we have to do is we have to determine the probability that A occurs or B does not occur. So that's the probability of A or the probability of B complement. And following the OR formula, the probability of A is 0.08, the probability of B complement is 0.85. And then you have this other spot when it's not mutually exclusive. A and B are mutually exclusive, but A and B complement are not. And so you have to realize that A is part of B complement. In fact, the probability of A intersect B complement is the actual probability of A. It's 0.08. And so you're going to subtract off 0.08 there. Now, the next piece of this problem says, compute the probability that either B occurs without A occurring, or A and B both occur. Well, we know that A and B don't both occur simultaneously because they're mutually exclusive, so their probability is 0. And really, you have to have the two overlap for this to kind of make some more sense. But so if A and B overlap, then this region that I have shaded here is B without A. It's B not A. And you'll see it written like this. So B not A. Okay, so we have to determine the probability of B not A, that's one of the terms right there, or A and B or both. And I'm sorry, A and B both occur. Okay, so that's looking for the intersection. Well, we know that part is 0. And by the drawing, if you think about B not A, okay, so that's B, and then not A is all the stuff out here. So all of B that's not in A is just going to be, I'm not saying this well, because there isn't any intersection, is just going to end up being the probability of B. So that should be 0.15. And that part is 0. Okay, I hope that helps.